So I'm actually also going to talk about what happens in the home environment and how well children do in school, but at a more fundamental level. Talking about gene environment interplay in the home learning environment, and some cautionary tales and also proposed solutions. And I'm assistant professor at the VU in Amsterdam in biological psychology. And in our department of biological psychology, we have 3 PhD students who are also part of Learn. Zeynep Tamimi, Sofieke Kevenaar, who's also here in the room. But Sofieke, you know already what I'm going to talk about, so also feel free to leave to go to the other room. And Pauline Demange and Sofieke and Pauline also presented posters earlier today that you may have seen. And in general, in the Department of Biological Psychology, when we look at educational achievement, we look at individual differences and look at genetic and environmental influences and the interplay, both using twin studies and studies in which we look at the DNA of participants. Today I'm going to briefly introduce this topic of genes and environment, and then I'm going to studies of studying the home environment, the home learning environment or home literacy environment, and how to do that if you have, if you do not have genetic data and if you do have genetic data. And on the way, I'll give you some take-home messages, but most of you will already be at home, so cannot bike them home. So we study educational achievement from the perspective of individual differences. So for example, if you test children on reading fluency, so how many words they can read in 1 minute, you get this very nice distribution. And here at the bottom end, you have the children with dyslexia. But if you want to answer the question, what causes these individual differences or what causes dyslexia, then you can answer that question at multiple levels. So the parents provide the home environment, but also the genes that they pass on. And it appears that they're very important in explaining variance in individual differences. And obviously there are other environmental influences, and within the child, you can focus with answering this question of what causes dyslexia or more general individual differences in educational achievement. You can answer that question at the level of genes, at the level of brain structure and function, or at the level of cognitive processes, or at the level of behavior. So there's not one answer to what causes these differences or what causes learning difficulties. You can study that at each of those levels, and at each of those levels you get multiple answers that all have a probabilistic influence. So at the level of genes, my first takeaway is that there are very many genes with all a tiny effect on reading ability. So it's not like a one gene with a big effect. And heritability is very high. So 75% of differences between children is due to genetic differences. But that does not mean that the heritability so high does not mean that you should just sit back and relax and you cannot do anything about it. So I have one study here to show that. So this is a reading intervention that I did together with my colleagues at the University of Amsterdam. And we selected children in kindergarten with a high risk of dyslexia. And they followed an intervention of 2 years. So there's no quick fix. You really need a long breath to improve children's reading fluency. And we followed them up and all the way until the end of primary school. And here are some results of that. So here are 2 groups with and without intervention. And both of these groups of children were at risk of dyslexia because they knew, for example, very few letters in kindergarten, but they do not have family risk. So both of their parents were average to good readers. But here within this group, you see this effect of having or not having an intervention, because in the no intervention group, there are more children who at the end of primary school are labeled as poor or dyslexic readers. But then, and these 2 groups, all of these children were also low in in letter knowledge and phonological awareness. But these children also, on top of that, have a family risk. So comparing the left two bars with the right two bars, you see this big effect of having a family risk or not. So within the group of children with family risk, many more children ended up with being dyslexic. But you also, in both groups, you see this effect, this big effect of being in the intervention group or not. So the intervention improves reading in both those with and without family risk. So you see both the effect of the genes here and the effect of the environment. So my next takeaway is that although the heritability is very high, it's not deterministic, and we should always strive to improve education to kind of shift the whole distribution. Then studying the home environment in studies in which you do not have genetic data. I'm going to start here with a headline in The Guardian, a very respected newspaper. And the headline is here that growing up in a house full of books is a major boost to literacy and numeracy, study finds. And then there is the study is basically a very impressive study. It's on 160,000 adults across 31 countries. And they see this across all these countries, they see a correlation between how adults or young adults literacy and numeracy skills and the size of the home library. So this correlation, that's very well established, but then the difficulty or my problem is in the conclusion. So here it even says here at the bottom, but a home library needs to contain at least 80 books to be effective. So it's all in a causal interpretation. So that the number of books that children grow up with has a causal effect on children's reading ability. So it's only thinking about this environmental pathways. Well, actually, luckily, most children grow up with their biological parents. And whenever you look at something that happens in the home or parental characteristics and children's outcome, my big takeaway message is that in those cases, you cannot ignore genetics. So if you think about this correlation, so the number of books that children grow up with is not a random number, because parents and children they share genes, because parents obviously pass on those genes. So parents and children are genetically related. You can imagine that parents who are better readers then also buy more books, get more books as presents. So this whole correlation between how many books there are at home and how well children do in reading could also be fully explained by the shared genes. So that if you do not account for that, that would be a genetic confound. And it could also be that both effects are present, so that there is this genetic confound, but also an environmental effect. But just from looking at the correlation, we don't know. Something in the chat, is that for me? No, I can't see the chat anymore. A side path looking at the relationship between reading ability of parents and reading ability of children. So we know from this American adoption study that in families with the biological families, so children growing up with their biological parents, that reading ability of parents and reading ability of children was correlated. But when they looked at adoptive families, then that correlation was 0. So the correlation between reading ability in parents and reading ability in children was only there in biological families, but completely absent in adoptive families. And we here in Amsterdam have also done a very different approach to study the same question, but in twin families. And we came to the same conclusion that if you look at the reading ability, then we can only find evidence that it's transmitted from parent to child through genes and not through environmental pathways. And because of that, I think we can use that piece of information in studies in which we do not have genetic data, but want to look at the influence of the home literacy environment. But because of this, I think we can use parental reading ability as a proxy for children's genetic liability or genetic risk for dyslexia or genetic potential for becoming a good reader. And I'm going to illustrate that here. So if you want to study the effect of the home environment or the home literacy environment, and we do not have genetic data, I'm going to argue that we can use parental reading ability as a proxy for this genetic risk or genetic liability. So here is on the y-axis, we have children's reading ability and the amount of variance that we can explain. So first, the number of books. So this correlates, in this particular study, it correlated 0.36 with children's reading ability. So it explains 13% of the variance. But then we should not jump to conclusions and saying that this is all a causal environmental effect. Because parental reading ability, so this is reading ability of both parents, explains 17%. And now comes the trick, is that in a stepwise regression, predicting children's reading ability, when you first enter parental reading ability, so that's the 17% explained, and then see whether your measure of the environment explains variance on top of that. Because, well, here it does. There's still some variance explained. The other variables that I looked at did not explain any additional variance. So for the number of books at home from this data, it seems that it still has an effect, which seems to be through the environment, but it's much more modest than just looking at the raw correlation. So my next takeaway is that the home environment is also partly heritable, so that measuring something in the home, so for example here how many books there are, it doesn't mean that that then has an environmental effect. It can also be partly a genetic effect. Or by measuring the home environment, you also pick up genetic effects. Then my final, getting to my final point. So here at the Netherlands Twin Register, we can also do studies in which we actually have measured the DNA of participants. So how can you use that in studying the home environment? For example, asking the question, do parents' education attainment affect offspring education? So can we study the effect of nurture while controlling for nature? And this is, I think, a very cool design. So for this design, you need parents and children and have them genotyped, so know their DNA sequence. And then if you know that for parents and children, you can figure out which alleles or which genetic variants have been passed on to the child, and you expect the variants, genetic variants, or the alleles that have been passed on to the child, that those that are related to education, that they influence or explain variance in children's educational achievement. So that's straightforward. But then you can also look at the genetic variants that have not been transmitted to the child. So the alleles that are only present in the parent, but not in the child. Because if they then explain variance in children's educational achievement, then that must be through the environment that parents create. So this is actually very cool that you look at DNA to see the impact of parenting. So at the right bottom, in other words, the non-transmitted alleles can only affect offspring through the environment via genetically influenced behaviors in the parents. And so you do not even need to measure here the parents in the behaviors in the parents. And what we see in this type of work is that at age 12, in the end of primary school test, that there we do not see yet influence of the genetic nurturing. So we do not find evidence yet for the influence of parenting, although in twin studies we do see a small influence. But when children or offspring, I should say, are adults, so in adulthood we do see a small effect of these non-transmitted alleles. So then my final takeaway is that by measuring the genes, you also pick up environmental effects. So that's like mirroring the other point. So here you really see the intertwinement. So in my final point is that when you measure DNA and see an effect of that DNA on, say, educational achievement, there's the intertwinement, because that effect can also go through the environment. And if you want to read more on this, then I can point you to this paper that just came out in Science of Learning.